Hello, in this video we're going to go through Learning Target 532, which is to use our interest formulas and to solve for a different variable besides the amount. So I just have this all written out for both of our formulas, like kind of the steps that you need to do if you're asked to find one of these amounts. So we don't have to go through all of them, but like for example, if you need to find P, you would simplify the right-hand side and then divide both sides by this, whatever the simplified amount is. So there's kind of steps for each of these that we can look back to if we get stuck. Let's just jump in though and look at a couple examples. So this one says, Michael has bought a boat for $17,000. Every year the value of the boat decreases by 5%. Write a function to model the scenario. This is the same as the 2.0 level, so this one just, we want to write a function. For this one, it does not say continuous, so we want to use our compound. It does not compound a different amount, so we just use a basic version of it. So 17,000 is our principal. This is our rate, and then we can plug those in. So part A, here's our function, 17,000. And then it says it decreases, so we're subtracting 0.05. And then we don't know the time, so that just stays t. So that's our first part. And then part B says, how many years will it take for the boat to depreciate to a value less than 13,000? If you aren't familiar with the word depreciate, that just means goes down, and then appreciate means goes up. So it's asking for when it's going to be less than 13,000. So we don't know the time, that's going to stay a t, but we do know that the amount needs to be 13,000. So I'm going to change A to 13,000. And then this I'm just going to simplify so it makes my life a little easier right now. And we get 0.95. Don't know why I didn't just do that in my head, but you know. And then t is the same. So what I need to solve for is t, and this is where our log properties and exponential properties are going to come in handy. So the first thing I need to do is I need to get this exponent alone, because I need to get this t out of the exponent, so I need to take the log. But before I can take the log, this 17,000 needs to go away. So I'm going to divide both sides by 17,000. And we get like a crazy decimal. And remember, we don't want to round too early, so I'm just going to leave that as a fraction. If we just cancel all these zeros, it is the same decimal. So 13 over 7 is the same as 13,000 over 17,000. So I'm just going to simplify it in that way. You could also, remember, use your calculator and do this math button and change it back to a fraction. So now that this part is alone, the part that has the exponent, we can take the log of both sides. So I have the log of 13 over 17 equals the log of 0.95 to the t. And remember, the reason we do this is so we can move that out into the front, so it's just there, and then I can divide by the log on both sides. So I'm going to take the log of 13 over 17 and divide by the log of 0.95. And we get 5.23. So we want to make sure that since it's a real world problem, we're answering correctly. Since each year the value decreases by 5% and it's asking for when it's going to be less, that means we need to round up because it's going to take more time to get to less than 13,000. This is the amount of time it takes to get to exactly 13,000. So we're going to say around 6 years because it'll need to decrease to less than 13,000. All right, so I want you to pause it, try the U-try, very similar to this one, and then we'll go through it. All right, so you can see I labeled my values. I have my equation here, and then again, same steps. Divide, take the log of both sides, move your exponent and then divide again to get your answer. And then remember, if it is only appreciating by this amount each year, we need to round up so it takes more time to get to more than 200,000. Now let's look at the next example on the back. So this one says, Lauren just won the lottery. After spending some of the money, she puts 20,000 in a bank account that earns continuous interest. So it says continuous. Again, draw your attention to that because that's a different formula. After 10 years, the account has this amount. What was the interest rate? So we're just going to start to label things. So this is our principal. That's what we put in. After 10 years, that's the time. The account has this amount. That's our A. We haven't seen that before where it gives you your A. And then we're looking for our R. So we're going to plug this in for A. Again, the formula for continuous looks like this. So our A goes in, our P goes in, and then we have E. We don't know the rate, and our time is 10. Okay, so then again, we want to start by like simplifying as much as possible, and that means getting rid of this 20,000. So we're going to divide both sides by 20,000. I was going to say, I don't think that'll be a fraction, so 2.01-ish. I'm going to try to keep that in my calculator so I don't have to round it. All right, so now we know that if we take the log of something that has the same base as this exponent, we can just cancel them out. So remember that natural logs have a base e. So if I take the natural log of both sides, the natural log and the e will cancel each other out, which will be very helpful because then we'll just be left with this exponent. So we have the natural log of that number that we have in our calculator equals 10r. And I know my last step is just going to be to divide by 10. So I'm going to do that in my calculator at the same time. So I'm going to take the natural log of that decimal, and then I'm going to divide by 10. So I get 0.069 repeating essentially. And so it's asking for our interest rate. Remember, interest rates are usually in percentages. So I would just want to change this to a percent by moving my decimal 2 spots. And so it's 6.9%, but I'm going to say around 7%. And that is our interest rate. So whenever you're asked to find one of these parts in your exponent, plug everything in and then take the natural log of each side so you can cancel that e out, and then you can solve for your value. Do that in the U try and then push play to see the answer. All right, so this one you had to really read because it says how long will it take you to double your investment. If you started with 5,000, double would then mean 10,000, so that would be your A. So I have everything labeled, solve, and then the one thing about continuous interest is that you don't need to like round really far up or really far down depending on what you're looking at. Because it's continuously compounding, you can just say around 13 years because it will hit that. It doesn't have to wait for like the year mark for it to actually earn interest. It's just always doing it. All right, this is the last type of problem that we're going to see. So it says Mackay invested $4,500 into a bank account for 10 years. So I know that's my principal, that's my time. His new balance after that time is this amount. That's our A. What was the interest rate of the account? So I'm looking for my R instead of in the continuous formula, in the regular formula. So we have our A, our P, and then we don't know our R here, and our time is 10. So we're going to simplify this a little bit differently than we did for here. So we can divide both sides by 4,500. And we get this number, 1.63. Again, I'm going to try to keep that in my calculator as long as I can so I don't round. And then I'm going to do the next few parts in my calculator. So here we have this 10th power, and to undo the 10th power, we need to do the 10th root. So remember to do that, you need to type in whatever root you want. So I want a 10th root, and then you go to math, and this x root. So it's the 10th root of that number that I had in my calculator. So use the ANS button to help you type that without rounding. So here's what I get for my 10th root, 1.05. And that gets rid of the exponent, and then you can see like all you have to do now is just subtract your 1 from this. But it looks confusing. You actually don't need to do a ton of work or any work with logs. You just have to make sure you divide, take the root, and then you can subtract. So we have 0.05 for our rate, which we know is 5%. All right, go ahead and do this last problem and then push play to see the answer. All right, and so I have everything plugged in here, and then this one, you just need to simplify this whole part. Like you can type this all into your calculator to get 1.48, and then just divide both sides by that number. So no need to do anything extravagant, you just simplify and divide.